And this one we're going to check for symmetry. So take a look. Imagine I have x squared plus y cubed equals 1. I want to test for symmetry, for example, with respect to the x, the y, and the origin. So to test for example, for symmetry with respect to the y-axis, you got to replace x with negative x in this equation. When I carry this out, I have negative x squared. So I'm replacing x in the original with negative x. And then the y is kept exactly as it is. And you keep everything instead equal to 1. Now, negative x squared is just x squared positive. You copy the rest of it because it hasn't changed, and it's equal to 1. So what you observe is that this form at this step is the same as the original equation. What that allows you to conclude, therefore, is that you have y-axis symmetry. That's what that allows us to conclude, just like that. So I'm going to do again x squared plus y cubed equals 1. And this time we're going to test for symmetry about the x-axis. So to do that, you have to take y and you have to replace it with negative y. And see whether what comes out is the same as the original. So in our case, let's see. I'm going to put x squared plus, and then you put parentheses. You replace y with negative y. You cube it, so that equal to 1. Then you have x squared. Now be very careful here. Let's work this out on the side, because it's a bit of a calculation, the negative y cubed. So you understand why it comes out a particular way. So I'm going to say negative y cubed. This means the following, that you distribute the 3 over to the negative 1 and the y individually. This is what it means. Take a look. It's as if you did negative 1 times y, and the whole thing is cubed. And then you distribute the 3 to the negative 1 and the y, so you end up with negative 1 cubed times y cubed. But negative 1 cubed is negative 1. So you put that back down as negative 1, then you can multiply back by the y cubed. So it ends up being back over here, negative y cubed equal to 1. And what you observe here is that these two, the original up top and the last one on the bottom, are different. And they're different because on the bottom, it's x squared minus y cubed. Now, on the top, it's x squared plus y cubed. The signs are different. So that, right, and that, they are clearly different. Therefore, no x-axis symmetry. So now let's finish this up one more time. X squared plus y cubed equals 1. We're going to test for symmetry about the origin. So that means x is replaced with negative x. And then y is replaced with negative y. And you want to see whether the new equation is equivalent or looks the same as the original. So in our case, when I do that, I'm going to have negative x squared plus negative y cubed equals 1. Negative x squared, as you have seen by now, is just back to positive x squared. Negative y cubed, as you have seen by now, becomes negative y cubed. There's a negative equal to 1. And now when you have a plus or minus, you can just equivalently write that as a minus. So then you can just put down a single minus. And as you can see, these two again are different. Those two equations are different because the original has a plus between x squared and y cubed, and the new one has a minus. Therefore, these are different. So we can say that we have no origin symmetry. And that is it. Thanks so much for watching. Leave a like. I'll see you in another video.